Welcome to this course, Quantconnect Zero to Live Trading, Python Edition. Before I get into the intro for this course, I should specify who this course is for. This course is fundamentally a beginner's course. It requires a very basic understanding of the Python programming language. So, I do assume going into this course, you know what Python is, you know what a variable in Python is, you know what a class in Python is, and lastly, you know what a function in Python is. These four things are the only prerequisites to this course. Everything else, you'll learn it as you go. Now this is where we're starting, from exactly nothing, a complete blank page in the Quantconnect IDE. This course is hands-on. It's a lesson-by-lesson practicals. By the end of this course, you will understand Quantconnect. You also will have a complete, definite idea about how to build and write fully working trading strategies without hand-holding. This course is designed to be short, but very quick in its effect. We will begin right off the bat by building your first trading strategy. Then, progressively, we'll increase the tempo, concept by concept. We'll get more sophisticated with each new lesson. This course is not about jumping between unrelated trading strategies. No. Instead, we stick to one trading strategy, we understand it, then we'll introduce new Quantconnect methods within that same strategy, then change its structure, then change its configuration, then we'll redo it again in a new lesson. We'll introduce new Quantconnect methods and objects and data types inside it, then change its structure, then change its configuration, then we'll redo it again in a new lesson, then redo it again and again and again, until you've learned Quantconnect purely by osmosis. Think of it like learning by quick, rapid reinforcement. That's the structure of this course. It's designed to be hugely accessible and also very insightful into how to build diverse, real trading strategies. By the end of this course, you will have gone from zero to complete live trading. So, congratulations in advance. Now, here is the exact reinforcement curriculum we're going to follow. So, let's get started. We're starting with a simple buy and hold trading strategy. Every strategy in this course thereafter builds on this exact structure that we're going to write here, meaning that by understanding this structure, you will understand how to build your own complex or simple trading strategy. This is the first line. It says, our class is named buy and hold, and it inherits from the QC algorithm. In Quantconnect, to write any trading strategy, Quantconnect expects a class as the first non-negotiable step, and this class must inherit from QC algorithm. This is the second non-negotiable step. Because our class must inherit from the QC algorithm, then we must import QC algorithm into the project. And so we added the only import statement we need. The import is going to be a constant we're going to keep writing in subsequent strategies because we must need and import QC algorithm. And right here, this is the general shape of any Quantconnect strategy. 1. It has a fixed structure. 2. To write any strategy, including yours, you must use a class. 3. The class must inherit the QC algorithm. 4. You must explicitly import QC algorithm. And that's lesson 1, short and simple. In lesson 2, we will initialize our class. Lesson 2, initializing our class. In lesson 1, we wrote a pass statement inside the class. The pass statement in Python does nothing. It's a placeholder. Python requires an indented block after statements like class, so pass lets us leave the block empty without causing a syntax error. Now, shifting our focus, if you remember what you learned about classes in Python, then you know the very first thing they need is a constructor. This is completely wrong to write in Quantconnect. Your class is not supposed to contain a constructor method. It's wrong, and that's the main point here. We'll talk more about this later on. So let's correct this. So if your class should not contain a constructor, then what exactly should go into it? The initialize is what should go inside of it. Initialize is a method that Quantconnect always expects your algorithm to have. It's a non-negotiable. And within the initialize is where you specify 4 things minimum. 1. The set start date. 2. The set end date. These two, 1 and 2, define the backtest window. They define when the backtest should start and when it should stop. Both take the same parameter types. They take a year, a month number, for example, 1 for January and 12 for December, and lastly, they take a day. The absence of set start date or set end date inside your algorithm, inside your initialize, will trigger the following defaults. For set start date, your strategy will choose 1998-11. For set end date, your strategy will choose today's date if not specified. So we are going to delete both of them to demonstrate this point. Continuing the explanation, we have number 3, set cash. Set cash is the starting balance for the backtest. It takes a number. The number can either be an integer or a float. If set cash is absent, it will trigger Quantconnect to default to $100,000. So to prove this point, we're going to delete it. Number 4, add equity. Add equity is how you add an equity into your trading strategy. If you don't want to add an equity because maybe that's not your asset of choice, Quantconnect provides other such related methods. You can use the IntelliSense of the IDE to see them. Add CFD, add crypto, crypto future, equity, forex, future, future contract, future option contract, index option contract, option contract, and so on. This leads me to coin a new term. We are going to consider these methods as belonging to one family. We are going to call this family the AddX family. And then about the AddX family of methods, there is no default, meaning Quantconnect does not seek to impose any one of the add methods on you or inside your initialize. It will not default to any if they are skipped. You must pick, then add it into the initialize. So we're going to leave add equity untouched. We already chose to add SPY. Almost all methods in the AddX family have these parameters: 1. Ticker, 2. Resolution, 3. Market, 4. Fill forward, 5. Leverage. These represent the parameters they can share in common with each other. This does not mean these parameters are only what they have. For instance, the add equity method, in line with the shared 5, has an extra 2 parameters it adds: extended market hours and data normalization mode. Here's a fun button. If you want to see the parameters a method has without the IntelliSense, then 1. Hover over the method with your mouse. Or you hover over the method with your mouse, hold down the Control key on Windows or Command key on Mac, and then click the method. It opens this page where you can read about the method parameters better. Ticker is the ticker string, for instance, SPY Apple. Resolution is the time frame of the data. If you've ever seen a TradingView chart, you know you can select and change its time frame. That word, time frame, the proper term is resolution. Market is the market or exchange or brokerage of the asset. Leverage is the leverage, exactly what it means. Fill forward specifies whether the previous data should be used when no new prices are available. For the add equity, ticker is the only required parameter. Quantconnect provides defaults for the other parameters, specifically for that of resolution. The default is minute. This means the data being returned to us will be the minute OHLC for the equity. The minute open, high, low, and close. It also means we can delete the resolution parameter in our method since Quantconnect will guarantee a default for us. And that is lesson 2, initializing your class. In the next lesson, we'll focus on getting your class to start receiving market data. Lesson 3, getting your class set up to receive market data. With the above, we see we have a very minimal initialize method from what exactly we started with. We also have not tested out certain things we had said we test. And the reason is because we lack a second non-negotiable method which Quantconnect mandates we have. OnData is a non-negotiable method in Quantconnect. It is how you receive your market data. Now, before I explain using analogies, I want to talk about our direction a bit. 1. We want to test those things out: the start date, the end date, and set cache defaults. But we cannot do that because OnData, at least from a beginner perspective, is a non-negotiable method in Quantconnect. It's the last non-negotiable method, so I want to explain OnData first and foremost. I will use an analogy. To explain using an analogy, think of pets. Let's clear this code. The above is a simple function, a rubbish function, but nonetheless, it is the shape and structure of a function, and it takes a parameter called my_dog. If you have a pet, you can't control when it needs food or belly rubs or wants to play. If it needs to eat, you give it food. If it needs belly rubs, you do that too. This sort of structure where you cannot control the flow of events because it is external means you can only respond to these events as they occur. A function designed to handle and wait for external events is said to be an event-driven function. The function we have written here is an event-driven function. It waits for the event to occur, then reacts to it. The typical naming style for event-driven functions is to use the prefix on. Quantconnect mandates your class must have such a function, the onData. It's descriptively what it means. The onData says, I wait for market data. Now, who is sending it? Recalling the dog example, the dog was coming to us, and this would then trigger the event-driven function. So you can say we were the ones waiting for the events. Now, who or what is coming to OnData behind the scenes to trigger it and say, hey, you event-driven function, I bring an event for you. When you add any method from the addX family into your initialize, Quantconnect sets it up. It becomes like a fire hose, ready to send data. Here's what happens. When you write, say for example, you write add equity inside your initialize, and you specify a resolution of maybe minutes. What you're telling Quantconnect is, set up this fire hose. Make it as fast as a minute. Then point it in the direction of that event-driven function. So what happens is when it sets it up, it fires the first bar, OnData responds, its body of code runs, it's done. It fires the next bar, OnData computes, gets done. And it keeps repeating for all bars or minutes inside the timeline of the subscribed data. Now here's a very fascinating question, but first of all, let's track where we've been. 1. We have the defaults we want to try out, still undone. 2. We now understand what OnData is and how it gets triggered. Now I wish for us to consider one last aspect of it, time simulation. Here's what I mean. In live trading, time passes naturally. The OnData just waits for the real data to trigger it, and it computes all inside its body and then waits again. But what about a backtest? How does Quantconnect simulate time? Because the thing needs to be triggered each minute. So imagine you want to backtest 1 year, but in minutes. That is your backtest start date and end date span a year, but your resolution is in minutes. Then by real-time logic, it should take 1 year, but it doesn't. It takes less than 20 seconds. So how does that work? I'll show you. Here we have 3 candles, each with time open, high, low, close. Now below is an instruction. Assuming you were the OnData event-driven function, which candle or time would you buy? The third one, the 10:03 one. See how easy that was? You did not take 3 minutes to decide. Why? You have the data and you have the instruction. So you can just scan down and point, here it is. This ability is what backtest is sort of doing. Each instruction or condition in your OnData gets checked against the data. So it's not trying to obey time linearly. Instead, it is treating time as a top-to-bottom list. It must check one by one. And because the engine can check it in near milliseconds computer time, then backtest is instant. This is the simple idea of it. So let's translate this into an initialize and OnData class structure to make it stick better. With this, you can start to see the exact shape of what is truly happening when you write a strategy for a backtest or a live simulation. When you write a strategy for a backtest, this is the very simplified picture of what the engine is really doing to simulate time. And that closes the matter on understanding the non-negotiable method on data. Turning our focus back to the lesson topic, the topic is getting your trading strategy set up to receive market data. Simple. Just add the on data, and as long as you are subscribed to an asset using the ADDX method inside Initialize, then no further action is pending. In the next lesson, we'll place a market order and hopefully we will test the defaults. Lesson 4. Getting your class to place a market order. So we're just going to slap a market order on the strategy so that we can settle the default points we've been carrying for over 3 lessons. The on data runs every single minute. We're not trying to have a lengthy backtest. Also, at the same time, I don't want to buy on every single minute candle since 1998. So I limited it to only buying on the implicit start date. It's only going to buy when the year is 1998 and the month is January and the time of day is 2 and the hour is 9 and the time is 50. The reason I chose 2 and not 1 is because 1998 1/1 is New Year's Day. So the market is not going to be open on New Year's Day. So we're just going to only buy once when it's this day. And at this moment, let's click backtest. So the first day it bought was 1998, January 2nd, because again, 1998 01 is New Year's Day. So it's not going to buy it then. So this is when the market opens. Let's see the set cash. The starting equity is $100,000. The end equity, well, we made a profit. So let's see the backtest when it ran up to. It ran up to yesterday. So, yeah. Okay, so that's done. I want to talk about something else. Look at how we are moving from single method to single method. And everything is just new and must be learned. This course isn't trying to teach you a bag of tricks or 100 methods one by one. Instead, the goal is we need a system, something systematic which can let us absorb methods far faster and thus move faster in our learning and skill of Quantconnect. This is the second to the last lesson before we start such a system. So what I am saying is this. This is lesson 4. In lesson 5, I want to lay the comprehensive ground for such a system. So let's go over there. I'll tell you more there. Lesson 5, Foundations. Welcome to lesson 5. The goal here is simple. We need a systematic way to study Quantconnect. The current way, I deem it ineffective. We're moving far too slow for my liking. At this rate, maybe we'd be done in 3 months. So, this systematic way we want to explore in this lesson rests on 4 pillars. So the four pillars are: number 1, local and global variables; number 2, security and symbol object; number 3, indicators; number 4, consolidators. Initialize and onData are methods. So when they run and get done, all local variables are deleted. A local variable in this case is one not attached to self, so it gets deleted. The variable myVariable1 inside the initialize will be deleted, while myVariable2 will not be deleted. The same behavior applies to the onData. Now, as you know, the initialize, it runs only once ever, and so the variables once deleted are gone. But for the onData, since it gets called again, they are reinitialized again and again. So this is the first pillar, and it's easy to grasp. The point is, local variables get deleted, global variables or class attributes persist. So let's move on. The second pillar is security and symbol object. The addX family of methods returns a security object. Every method in Python can return a value. The same applies to the addX methods, add forex, add crypto, etc. Each method of the addX family returns something when you call it inside initialize. It returns an instance of the security class. Because of this, we say it returns a security object. So let me paste this into our sketchpad. This is a helpful visualization for what a security object looks like when laid out in only text. It has these things: symbol, it has security type, resolution, exchange, price, holdings, etc. Again, this structure is imagined into text. Now, the entire point of this second pillar, so it doesn't rub off as meaningless, is that we can now do this. The point is that we can save returned security objects, or we can save only the symbol object. Look at what you just stored. Variable 2 is holding the security object. The whole thing, symbol, security type, resolution, exchange, etc., all of it. Variable 3 is holding something smaller, pulled out of that same object. The symbol. The symbol isn't the ticker string. For instance, it's not the SPY, neither is it the EURUSD, EURUSD you typed. It's the actual object Quantconnect uses internally to identify that exact security elsewhere in your code. And here's why that distinction earns its own variable instead of being nonsensical. The reason is because almost nothing downstream wants the ticker string. For instance, when you want to add an indicator on top of your security, it asks for the symbol object, not the string, not AAPL. When you want to check a price, it's the same thing. None of them are asking for the ticker string, so it becomes important for us to save it, the symbol object. Also, here's a fair question. Why does Quantconnect not just use the ticker string everywhere? I mean, we just simply wrote it inside here, so why not use that? It's simple enough for a human being. Now, here's the problem the ticker string cannot solve on its own. A ticker isn't a permanent name. It's a label that can point at different things depending on the moment and market. For instance, Facebook once traded as FB for years, then became Meta. Same company, same shares, different string. Another example, a futures contract called ES isn't one thing at all. Every quarter it rolls into a new contract with a new expiry, still called ES, by everyone trading it. If Quantconnect matched everything by ticker strings, it would have no way to know whether ES today means the same contract as ES 3 months ago. And for backtesting of historical data, that ambiguity would quietly kill any certainty you can have about your results. So the symbol object exists to remove that ambiguity. It's not just the ticker. The ticker plus enough extra information, for instance, which exchange, which security type, which expiry if there's one, basically to point at one specific thing and never accidentally at another. So the symbol is what Quantconnect uses internally because it's precise enough for a machine. And that's literally this pillar's entire point. The point is always remember to save the symbol object. Now, let's go to the third pillar of the foundation. And don't worry if this is still looking disconnected. Yes, I can see that too, and I can assure you it all connects to a very beautiful and deep foundation. So, the third pillar. The third pillar is indicators. You already know what they are. My simple goal for what the foundation requires is to show you how to find and add indicators into your strategy. And it's a simple thing to do. To find and use an indicator in Quantconnect, simply search self dot. That's all. Literally the whole pillar. So let's go try it. Let's search for MACD. There it is. RSI. Same thing. EMA. Same thing. Just to be sure, let me open it so I can show you that. Basically, it's the indicator. Creates an exponential moving average indicator. Let's search SMA. Creates a simple moving average indicator. Let's search the DEMA, double EMA. Double exponential moving average. Let's search BB, Bollinger Bands. Bollinger Bands. Let's search TRIX, one of my favorite indicators. Creates a new TRIX indicator. Now the last pillar is the consolidators. To introduce it intuitively, let me clear this. Let me clear from below. So let me paste this problem and let's consider it. Here's a problem to kickstart consolidators. Problem 1. Suppose you want Euro USD to have a resolution of 15 minutes, but resolution as a parameter only has the following values: tick, second, minute, hour, daily. There's no resolution .15 minutes. So what do we do? Here's a simple explanation for how a consolidator works. Think of the fact that 60 seconds consolidates into 1 minute. For instance, if you get 60 seconds, you call it a minute. 60 minutes consolidates into 1 hour. 24 hours consolidates into 1 day. As you can see what is happening, you can select the nearest base resolution, then you can add it and add it and add it until you get the desired resolution. That's consolidation in practice. So, 15 1-minute candles consolidates into 15 minutes. 3 1-minute candles consolidates into 3 minutes. 16 1-hour candles consolidates into 16 hours. So in simple English, consolidators help us get custom timeframes from native resolutions. But that's not all they do. Consolidators also turn that same OHLC data into a different bar entirely, such as Renko, Heiken Ashi, range, volume Renko. So with consolidators, we easily get custom timeframes or custom bar types. How wonderful. So that brings us to talk about what a consolidator looks like in practice and how to work with it to get custom timeframes and custom bar types. For each symbol we have here, we are saving its symbol object, as you can see. And also we added native resolutions to it, resolution.minute. But now let's say for Euro USD, we want 15 minutes resolution. And for Microsoft, we want 3 minutes resolution. So let me write what a consolidator for them would look like first. Consolidating follows a fixed 3-step pattern. By that, I mean you're always writing the same exact thing. What you're looking at is this exact thing. It is always 3 lines per security or asset. We wrote for the EURUSD its own 3 lines, and for the Microsoft its own 3 lines. There's no creativity to it. And then let me give you this simple gist, not like an aloof teacher in a general classroom dictating points, but like a friend. So here's what's happening in the simplest way possible. See this guy. You already know him. It's the symbol object. This guy. Now, typically, once you register a native resolution, you are directing the fire hose of data into the standard event-driven function of Quantconnect. This guy, the onData. So this guy comes and then says, this resolution needs to be consolidated. What is consolidation? It is we are going to be stacking it brick by brick to create the time you requested. It continues talking and says, in line with the standard pipeline which already exists from Firehose to onData, I want us to create a new one. That is, the onData stuff will still be happening, but now we will have a second Firehose. They will sit side by side. It then continues. The Firehose should be sending its data into the consolidation factory. Specifically, this one that I have written, trade bar consolidator. Also, when I use the word factory, I'm using it in a normal English way. A factory is where things are made, like clothes, etc. A factory turns raw materials into finished goods. This factory, trade bar consolidation, factory and friends, takes normal OHLC bars as raw materials and then outputs a consolidated bar. Just to give you an idea of what I'm trying to say, there are other types of consolidation factories. There is Renko, there is volume Renko, there is quote bar, there is trade bar. They differ in only what raw materials they take and what they give out. So back to this, our factory, trade bar and friends. It manufactures trade bars. It requires only a single parameter, the new resolution that you want, or you can say the time. And how we write it is inside the factory, is inside as a parameter, is via the time delta. Time delta is the parameter it accepts to help specify exactly the resolution you want. Time delta lets you specify whether microseconds, milliseconds, seconds, minutes, hours, days, or weeks. Here I'm using minutes. I could have said days. I could have said seconds. I could have said milliseconds. It doesn't matter. But I'm going for minutes because that's what we said. And so it's going to be taking each new bar from the fire hose and then adding and consolidating them, adding and adding until it gets the count you specified. In this case, 15 minutes count of them. Once it does that, it saves it into your persistent warehouse. Think of it like you have a warehouse. It gets 15 1-minute candles, combines them and says, yep, I'm saving this as 1 bar into your warehouse. So it stacks this 1 by 1 for each 15 minutes count. It is saving the new consolidated bar. Now, this guy, this snippet, just the word, or the phrase rather, data underscore consolidated, he's a watcher. A watcher in the sense that once he sees that new data has come into your warehouse, he's the one that says, okay, I need to tell the user's custom event-driven function. In this case, you have to give him an event-driven function to call. And then exactly what you're thinking is what I'm thinking too. You make one up. Here's how you do that. Anytime you use a consolidator, it's going to require you to create a custom or custom event-driven functions. Let's slow down on this line because it looks like a normal function until you hit the second parameter, sender. Self, you already know, it's the class instance, same as every other method you've written in this course. Bar is the actual data you want. It contains the open, high, low, close. Think of it like doing bar.open. I'm just giving an example, not saying this is actual syntax. So you can think of bar not as a single thing, but like an object or array. Sender is the one that looks strange because you never really sort of use it, and you also at the same time never asked for it. Sender tells you who called your event-driven function, in this case, the consolidator. And don't worry about what we're saying here. You don't need to get the whole point quickly because we're going to go to practicals and exercises in the next lesson, and that's where this thing will really stick because we'll just be using them as blocks. So the entire point is just the syntax is 3 lines. You just write it, that's all. So we now have our native event-driven function and our custom event-driven function. And that is consolidators in simple gist like English. Now, before we end this lesson, I want to add a very important point. Suppose you want an indicator the normal way. Like we said, you use self dot. And that's exactly what we said in the rules. We said, to find and use an indicator in Quantconnect one way, look at this word here, the phrase one way. It's not the only way, it's one of the ways. And so the question here is, what is the second way? Now, suppose you want to add an indicator the normal way, you use self dot. But when you want to add an indicator that has or that uses consolidated data, there's a second way, and this way is what I want to explain. This is an example. We added the simple moving average to the Euro USD resolution of minute. But by adding it this way, the implicit assumption we're telling the engine is this data is not consolidated, but it is. Here is what this is saying. Suppose you want a simple moving average SMA on the 15-minute consolidated Euro USD, then Quantconnect has a simple 2-step process to achieve this. Step 1, write an indicator function. So I'm going to delete this because this right here is basically assuming, and the old way assumes that the data is non-consolidated. So I'm going to delete that because the data is actually consolidated. Simply type the indicator name, you will see its constructor. So for example, suppose the name is simple moving average, I'm going to just simply type it. And that's all. If it's a MACD, that's all. If it's let's say DEMA double, basically you get the point. You just always step 1, simply write the indicator function. You can fill in the parameters if you want. For instance, this is the 14 period. This is the 40 period. This is the 50 period. You get the idea. So I'm going to put the 14 period, remove this. Then step 2, register the indicator function. This is the next line you do. You give it 3 things. The first thing you do is you give it the symbol object. The second thing you do is you give it the indicator function. The third thing you do is you give it the warehouse of your consolidated bars. These three things all the time. So let's fill it out. If we want to basically give the Euro USD right now a simple moving average 14 period on the 15-minute Euro USD, all we just do is we write the symbol. And the symbol is self Euro USD indicator function. So I'm going to have to name this. I'm just going to choose to name this something like yes, this is better. And the last, I'm going to give it the warehouse. And that's how you register the indicator. The reason you need to register it is so that you can avoid feeding the indicator manually. Quantconnect just does it for you. Again, we'll meet these things in the next lesson. This just serves as a precursor to them. So in summary, there are two ways to add an indicator. The first way is self-dot. The second way is an indicator function, also called a constructor. Now we're done with this lesson. So the question you might have is, why is any of this important? Well, let's go to the next lesson. Then you'll see it clearly. I'll meet you in lesson 6. Initialization reinforcement exercises 1 to 3. Lesson 6. Initialization reinforcement exercise 1 to 3. We come to lesson 6 and immediately our goal is to make lesson 5 worthwhile and make sense. We are not revisiting any of the concepts. That's not what I mean. Instead, I want to show you what happens when you now have that exact minimal foundation of pillars we constructed in lesson 5. All the things you can now do with it. Said in a better way, in order to learn Quantconnect, you might be thinking, maybe I need to spend 6 to 9 months learning theory to get started. That's a personal choice, but it's not the only way. I am saying this course is the opposite. It provides the same depth in 10 lessons, so it can be covered in a single day. So let's get started by going back to the sketchpad. And don't worry, this lesson is actually very fun. The aim is to have you learning by repetition and osmosis. Right here, we have 3 actual trading strategies. We have trading strategy 1. We have trading strategy 1, trading strategy 2, and trading strategy 3. These are not baby strategies. These are actual how you would think type strategies. Each part, I've purposefully left out the logic part, part that does something technical or fundamental with parts 1 to 6. For instance, it could be that you want to be looking at Renko bars and the MACD while also evaluating each candle on the 1 minute across all forexes, looking for setup, etc. The important point is this. Every trading strategy that is not machine learning in nature or super discretionary, basically something truly exotic, every single one obeys this single truth. It always can be rewritten into this format. The general format of 1, the assets you wish to trade. Basically, I want to trade, then you specify. 2, the bar types of those assets. 3, the resolution for those assets. 4, the indicators on those assets. 5, the backtesting range or trading range of those assets. 6, the amount of starting cash. And 7, the logic that describes how your strategy should be buying or selling while managing risk, basically your logical strategy. And think of it, that's actually how a normal human being writes a trading strategy. You pull out a sheet of paper, maybe you already have the assets in your mind, maybe Nvidia, AMD, QQQ, Solana, and New Zealand dollar. You write those down, you say, I want to trade, then you write the list. Then once you have the list, then the next bit is to say, okay, what are the bar types? Okay, that is, if you're setting up a chart, what are you looking at? Is it OHLC candles, Renko, volume Renko? Then you set the resolution, then you add your indicators, then you basically select the time you want to look at, the duration, let's say from June 1st, 2020 to so and so date. Then also in the settings panel, you would have added your starting cash with your brokerage. And that's actually how a normal person says, I want to write my trading strategy. And so this is the general format. Lesson 6 is exactly this truth. Lesson 6 is coming to say there's a general format to writing a trading strategy. This general format, when you write into it, because it has a well-known documented translation schema, then writing your own complex or simple trading strategy in Quantconnect becomes easy. Let me show you this schema. Number 1, to the question of how to write assets you wish to trade, Quantconnect already answered it beautifully for you. Use the ADDX methods. Make sure you save the security and the symbol of each. To the question of write or specify the bar types of your assets, Quantconnect already answered that beautifully for you. Use consolidators. With consolidators, you get different kinds of bar types. To the question of how to write the resolution for your added assets, again, still answered beautifully. Either you're going to use the native resolution or you're going to use consolidators. You pass a consolidator the value. Number 4, to the question of how can I write the indicators I want for my assets, you're either going to use self dot or you're going to use the constructors, basically indicator functions. Number 5, to the question of the backtest range and the starting environment and starting cash, it says use set start date, set end date, and set cash. As you can see, the translation schema basically is answering this standard general format. You say you want to trade, Quantconnect has provided the ADDX methods. You say, I need bar types, Quantconnect says fine, use consolidators or you use the ADDX method. You say, you want to specify your resolution. So what I'm just trying to say in simple English is this. If you can write it like this, then this translation schema is saying, no need to sweat it. Quantconnect has already done it for you in a very simple manner. So that brings lesson 6 into full focus because the entire initialize method is designed for you to quickly get started. Things that would require lots of mouse clicks on other platforms or 14 charts in TradingView, you can just write them down quickly inside your initialize. So with lesson 6, the goal here is to practice translating from this standard general format using the translation schema into pure Quantconnect code. We shall practice by translating these 3 trading strategies. They are very robust, so let's get started. So let us go do trading strategy 1. We are going to open the sketchpad in split view. So if you don't know how to do that, just tap on it. This is split view button and done. I'm going to close it over here. So number 1, we wish to trade Apple, Google, Microsoft, Bitcoin, and USD, basically USD-JPY. Apple, Google, and Microsoft are equities. USD-JPY is Forex. Bitcoin is crypto. So already That translates into 3 add equities, 1 add Forex, and 1 add crypto. We are also going to be using their dot symbol. Remember, we want to be saving the symbol object. So we're going to be using dot symbol at the end. So how do you write this? This is the translation. So we've done that. Look at how easy that was. Let's look at number 2 and 3 together, bar types and their resolutions. Apple is standard OHLC with native resolution of daily. So basically, we're going to come over to Apple and say resolution dot daily. Okay, better. Google, we are going to use the Renko consolidator. And remember what we said about consolidators, 3 lines always. So now look at what this consolidator is saying. First of all, it's saying that the bar type is Renko, so obviously 3 lines, but it's now saying Google is $2 bricks. Now, if you followed my idea of Renko consolidators being a factory, then the factory here is $2. So we're going to put that in. That's the brick size. So I'm going to add that. And that's literally all. We have added the Google Renko consolidator. And as you can see here, the line is yellow because we need to add the on Google bar, basically the event-driven function. So I'm going to come down here. I like waiting for the IntelliSense to show it. So self, the next thing is sender, and the last thing is bar, pass. Did I spell it well? Yes, I did. So the next thing is Microsoft. That's the next thing, and it's 3 minutes. We are going to use the standard 3-minute OHLC consolidator, and basically it's a trade bar consolidator. So let's add it. As you can see, easy again. So look at the minutes we added, 3 minutes. So we can already specify this as resolution.minute, but again, that's the default, so there's nothing to specify. Moving onwards, the next is BTC and its volume Renko. The volume Renko takes the volume Renko consolidator. And then we said it takes volume, not pips, not bricks. It takes volume. So what is the volume here? The volume here is 500 Bitcoin. 500 is the volume. So we're going to add that. So let's add that. So that's done. Now let me write the 2 event-driven functions basically on Microsoft bar and on BTC USD bar. Let's copy this one here and paste it twice. I'm going to change this to on Microsoft and change this to BTC USD. And we are done. Going to save it. Correct. Now the last is basically the USD JPY. It's OHLC, and the resolution we want is 4 hours. We're going to take the 1 hour as the base resolution rather than the 1 minute. So I'm going to come over here and then say resolution.r. I would have liked to line these up, but I'm just going to, oh, well, like that. I should already do it. Yes. So for R, we are consolidating from the resolution R. So now My goal is to ask you, what do you think we would have used? Option A, the Renko consolidator. Option B, the trade bar consolidator. Or option C, the volume Renko. What do you think we're going to use? If you had said trade bar consolidator, beautiful, but just there's a slight nuance there. And what's the nuance? Forex doesn't work that way. There's no single exchange where USD JPY trades. Because of that, and because the structure is just banks and brokers quoting each other a bid and an ask, a bid and an ask, there's no official last price at all. Only quotes. So, the OHLC you get from USD JPY is going to have to be built from quotes. So the idea I want you to have now is that if it comes to Forex, you're going to be using a quote bar. If it comes to other things like, let's say, crypto, equities, and others, basically you use a trade bar. But with Forex, you use a quote bar. So let's put that in. Let's scroll down. And so as our 4, and we basically used the quote bar. So let's also add its event-driven function. Okay. So we have done 1, 2, and 3. Let's go to the indicators. Now, looking at the indicators, each one basically has about 1 or 2 indicators. And remember what we then said, remember our rule, we use self dot to add native resolution indicators. And then for the non-native ones, that is the ones that take in consolidated data, we use indicator functions. So for Apple, we are going to be adding 2 simple moving averages, the 20 and the 50. And then what is Apple? Apple is purely native. So there's nothing much to add. Well, let me even add it down here. And that is all. Now for Google, looking at it, basically it's obviously consolidated data. So we should use indicator functions. And then the indicators it's telling us is the RSI and the MACD. RSI is short for Relative Strength Index, and the MACD is short for Moving Average Convergence Divergence. So I'm just going to put that there. Let me put that in. I should have copied this. So we added the Relative Strength Index, its indicator function, and the Moving Average Convergence Divergence, its own. The same settings, we added 14, 14, and the fast, the slow, and the signal, we added that too. The default is typically exponential, so I just let that in. Now, we registered the indicator, and this was what we were saying in the previous lesson. It takes the symbol, it takes the indicator function, and lastly, it takes your warehouse, basically the consolidated data. Once you do that, that's the second step, and that's all. Quantconnect starts to handle the indicator behind the scenes. Now, the last is basically, or the second to the last, sorry, is basically, or third to the last, actually. So now the next is Microsoft. So let's do for Microsoft. Let's look at it. It's OHLC, but it's consolidated data. So can you guess what it's going to take? It's going to take indicator functions. So let's add that too. So we added its indicators, the 9-period EMA and the 21-period EMA. and then we registered the indicators. So let's move down. Let's go to BTC. BTC takes the ATR, the average true range, and the 200 period EMA. And basically it's consolidated. So again, it's still indicator functions. So let me add that in. And so we have that. Now the last is the yen. And so it's taking the OHLC, but with 4 R's. So that means it's consolidated. The indicators are stochastic and the 50 period SMA. So we're going to add its indicator functions and then register it. Let me first of all add this for USD JPY. And so that's all. Now the last thing is basically number 5, and I guess number 6, but they can be considered as one. The backtest range, that is basically set start date, set end date, and set cache. So let's crown it by adding the set cache, set start date, and the set end date. Look at how easy that was. This idea would have taken numerous and countless lines in another programming language, but here we are done. Look at this. Just you breeze through it so quickly. Now let's go to trading strategy 2. Let's do it. So I don't know whether I should clear this, but I'm just going to clear it. Okay. I'm going to save it in case we need it. Then I'm going to clear it. Trading strategy 2. So let's begin with the I want to trade statements. SPY, Tesla, this is silver, this is Ethereum, and this is the Australian dollar pair Forex. So this is what we wish to trade. Now, SPY and Tesla are equities. Silver is a Forex. Ethereum is crypto, and Australian dollar is Forex. So we used the ADDX methods and also saved their dot symbol object. So let's add that. And done. Let's look at resolutions and indicators. SPY is standard OHLC. It has a 30-minute resolution. That's non-native. So we are going to consolidate off the 1-minute base. So I'm going to add. Well, it's already default, but I'm just going to still add it. Resolution dot minute. Now for Tesla, we are going to use a Renko consolidator. The resolution is a 2-point brick, and so the Tesla brick size will be exactly 2 points, basically 2. So we're just going to add that. So we have added SPY's OHLC consolidator of 30 minutes. And right here, let's add the event-driven function. Okay, that's everything for SPY. Now the next is Tesla. For Tesla, we're going to add a Renko, and the Renko, the brick size is 2. So we're just going to add a Tesla brick size of 2 with the Renko consolidator. So that's for Tesla. Let's add its event-driven method. Now the next is XAG Silver. So for Silver, we're looking at it and it's OHLC and daily. That's standard clear native. So we're just going to add a resolution of daily. Okay. Now, the next is Ethereum. Basically, it's a standard OHLC, as you can see right here, and the resolution is 15 minutes. So it's non-native. We have to consolidate off the 1 minute base. So that's what we're going to do. We're going to use a trade bar because it is not Forex. So we have added the 15 minute, and let us then, that's why you see the yellow line. So let's add that. Now the next is, and this is the last, Australian dollar. It's basically standard OHLC with a very standard resolution, so it's non-native. Now remember, Forex also has no real trade volume, so if this were supposed to be consolidated, we would have used, quote bars. So we're just going to add this into the whole thing. Now let's go to the indicators. Now for SPY, it needs the RSI and the MACD. For SPY, basically it's asking for the 14-period RSI and the 12.26.9 MACD. So we're going to add their indicator functions, and then we're going to register them. So let's quickly do that. And that's done. We've added the RSI 14 and the MACD. Now, the next basically is the indicators for the Tesla. So again, we add the same. It's asking for the 10-period ATR and the 20-period SMA. And remember, it's basically consolidated, so we're going to register. We're going to use indicator functions, then register. So let me write that there. Let me remove this. Makes it shorter. And so we've added the indicators. Now let's go faster. So we have silver, it's OHLC, and it's daily. So we're not going to use, basically it's native. So we're not going to use any indicator functions. We're just going to add the, what's it asking for? 50-period SMA and the 200-period SMA directly. And so that's it. Now the next is basically the ETH USD. And it is going to use indicator functions since it's consolidated. It's only asking for the stochastic RSI. So we're going to add that. And that's done. Now the last is the Australian dollar, and it's asking for the 21-period EMA and 14-period RSI. And as you can see, basically it's native resolution. So there's no consolidation or registering here. So that's done. So the last is basically 5 and 6, basically the backtest period and the set cash. So we're going to add that. We could add it anywhere, so I'm just going to add it here. And so that's it. Look at how easy again that was. So let's go to trading strategy 3. I'm going to clear this. I'll see you there. So We wish to trade NVIDIA, AMD, QQQ, Solana, and New Zealand dollar. NVIDIA and AMD and QQQ are equities. So New Zealand USD is Forex. Solana is crypto. We're going to use the AddX methods and also save their .symbol objects. Done. So now let's look at the bar type and resolutions. Looking at that, there is no native. There's no native. So we're just going to consolidate our way to the end. So let's begin. The first is an OHLC of 5 minutes. We're going to use a base of 1 minute. Renko of 2. The OHLC of 2 hours. We're going to use 1 hour. Volume Renko of 2000. And the OHLC of 4 hour. We're going to use a 1 hour base. So let's proceed. Now for the New Zealand dollar, remember, if it's a Forex, we can't use the trade bar. We are going to use the quote bar. Just reminding you. So let's do it. Now we've added all the consolidators. Let's add the indicators. NVIDIA takes the Donchian channel and the volume-weighted moving average. So we're going to add that as indicator functions because it's consolidated. The next is the AMD. And the indicators are the EMA and the ADX. The 9 and 21 EMA and the ADX. The next is QQQ, SMA and the MACD. The next is the Solana. Indicators here are the 12 and 26 EMA and the RSI 14. The last is the New Zealand dollar, which takes the Bollinger Band 20 and the ADX. We're going to add the last thing. And that's it. And we reach the end of this lesson. As you can see, writing your initialize is like Lego bricks, and that's the essence of what I was trying to show. On one hand, you might begin to have a fear that, oh, I don't know how to code, I don't know how to do this, but as long as you can write it within the translation schema, then you're good to go. And so that's the end of this lesson. Now in the next lesson, lesson 7, we begin this systemization, but for on data. It will be very interesting also and even more fun. I hope you stick around. Lesson 7, Foundations 2. Welcome to Lesson 7. And then how we ended Lesson 6 was we said we'd begin the same systemization, but for on data. So I want to direct our focus to that task. I want us to start systemization. So to begin, I'm going to start indirectly, or at least softly. So just put off the topic for a while in your mind. And let's start with a simple, ordinary conversation, like two friends talking without there being any rigid guidelines or goal we have to follow. So let me delete this so that you can put it off your mind. So let's say you already have a trading strategy. Here's an example, the simplest possible one you could write. Let's go write it in the main.py. We're going to use a split page, so let's get started on it. And so having this algorithm, we can write it fairly quickly. I simply used numbered comments to save our time, but you get the idea. The only part that we haven't written for is the on data. All we have there is a pass. So what do we write inside the on data? Now here is where I want to get real honest. You could try to learn more and more Python. In fact, you could learn the syntax in an afternoon, honestly, because it's that easy and there are a million courses on it. But that's not the problem, and that's very telling because here's what we can say is true about what it takes to know what to write inside on data. You could have the English written down. Look at it. It's just 2 sentences, 7 and 8. 2. You could learn more and more Python for the next 10 days. There are so many courses on it. But then, these 2 alone are insufficient to the task of knowing what to write inside on data, because on data expects a shape defined by Quantconnect. What I'm getting at is this. Your mind is blank because you're trying to invent a shape. What do I mean by a shape? On data is easy, very easy to write. To see why, you have to understand that on data takes a shape, a defined shape. Just like Initialize had a defined shape, and look at it. It's right there. The shape of Initialize. On data has one too. Once you see this shape, writing a strategy stops being, how do I even do this, and becomes, let me translate the idea I have in my head into this shape. That's a much easier problem. And so that gets to the heart of what I am trying to say. What is the shape on data takes? To see the shape on data takes is to look exactly at how it is built. On data is an event-driven function that gets called for every single bar or tick, for every single data item. On data is always being called. Imagine there's a principal's office or maybe your boss's office, and there is this spreadsheet. And then for every single row, your boss keeps on calling you. On data is in this exact situation. It is being called every single line of the spreadsheet. The reason for the call is so that it can answer 3 questions. These 3 questions are: 1. Is it allowed to act right now? 2. Have its signals fired? 3. Does it get in or out here? Written this way, these questions seem abstract. So let me ground and simplify them. In simple English, this is the shape. And this is so important that let me write it like math. You know, in math, you write 3 equal to 1 plus 1 plus 1. An equation is not a suggestion, it's a fact. Likewise, what I am saying is this. Every strategy you will ever build, simple or complex, is a combination from these 3 things. This is the mental shift this lesson is going for. It is saying, stop trying to write a novel inside your own data. A novel is open-ended, shapeless, and very messy. Instead, keep this shape as the foundation, then you'll be writing on a template. You are wiring the equivalent of a 3-chip processor, safety, signal, entry, a CPU or chip or template with 3 parts. This brings us back to our task. Systemization of OnData. The minimum structure that OnData requires is the 3-chip. This is the minimum stable structure it can accept, which is complete and can be used to write a trading strategy. So, the essence of this lesson is to teach you the elements of the 3-chip. So that in the next lesson, we can start to use that template to write strategies. That is the systemization here. So with that said, let me spur up our curriculum for this lesson. Here is the list of things we're going to learn to make this happen. 1 is ready, 2 set warm up, 3 is warming up, 4 market order, 5 limit order, 6 portfolio. So let's get started. Let's start with is ready. What is ready? Say you're building a basic strategy, buy SPY when its price crosses above the 20-day simple moving average and use a market order to get in, buying 100 shares. Let me simply paste the simple and heavily commented out solution so that we can use it to reason without the baggage of writing it properly. So here it is. And back to what I was saying, if you look at the SMA 20, the issue is our SMA 20 here has a resolution of daily because the symbol itself has a resolution of daily. Furthermore, the SMA 20 needs 20 days of data before it can compute anything meaningful. This is the period we set. So on day 1, it has no computed value. Day 2, same thing. Up to day 19, it still has no value. Your SMA 20 is just not ready because it needs 20 days minimum. Quantconnect has a way to check for this. In Quantconnect, we make use of the indicator property isReady. It is a property available for every single indicator in Quantconnect, meaning that if I want to check if a particular indicator is ready, I'll simply do this. So in simple English, it's a query to find out if your indicator is ready. It returns either true or false. So then, here is how you can use it in your strategy. And this usage forms the basis for the first non-negotiable thing that your OnData should contain. If we had 10 indicators, then we would need to have 10 isReadies. And that's how we use isReady. It's the first non-negotiable block to be put inside your OnData. Now let's talk about setWarmUp. It's also in the same ballpark as isReady, so much so that we can use the exact same examples. In order to explain setWarmUp, let's look back at the definition of isReady. isReady is the safety mechanism that ensures you are not using incomplete data to trade. But I also want you to think of what's happening as you are skipping those bars. You have a fixed start date. Let's go see ours. The start date is the new year, so look where we set our end date to. The end date is set to 20 days later. So what this means is we are going to skip 20 days so that the simple moving average 20 indicator can be ready. But that's the whole length of the backtest. We lost the entire backtest to doing nothing. This is where setWarmUp says, I am here to help. When you use setWarmUp, you're telling Quantconnect to warm up the indicators. How you do so is you give the function a bar count and a resolution. The bar count specifies how many bars backwards it should load from the set start date bar or time. The resolution specifies the resolution of the bar themselves. Here's an example. If the start date of this is New Year, then excluding the start date itself, it will load 20 bars going backwards. If you were to count them, you would have 20 bars plus the start date 21 bars. The idea of set warm-up is this exactly. You write in the number of bars, then you write in the resolution of those bars. Set warm-up makes sure your indicators are already accurate from day one of real trading or backtesting. Now let's look at number 3, is warming up. Is warming up is a Boolean property on your strategy itself. And here's what I mean by that. When you write self dot, you can see is warming up already. And so the reason you can see it is because it is a property of the strategy itself. It does not need you to go through any indicator or route to access it. You use it to determine if the warm-up you installed or placed in your initialize has ended. If it is over, it flips to false, else it will still be true. And something I never addressed was, how does this warm-up thing work? Yes, we understand the definition, the method, and now this Boolean property. But I thought we said initialize runs once. Yes, that's correct. Initialize only runs once. So if set warmup is called inside initialize, shouldn't the warmup finish first during the one run of initialize? Meaning by the time onData ever gets called, warmup should already be done. Because why do you need to check is warming up inside the onData at all, when onData can only be called when initialize is done forever? The answer is simple. Initialize doesn't actually run during the warm-up, it just requests it. Your foundation is still correct. Your view of set warm-up is what is wrong. When you request warm-up, it is not tied to this picture. Calling set warm-up 20, resolution.daily inside initialize is like placing an order to a food vendor to give you 20 daily bars of history. So let's look at this code again. Initialize finishes right here. It finishes after placing the set warm-up order. It doesn't sit there and wait for the food, that is for the bars to arrive. It is done. Your onData has kicked in. That is, what you assumed wrong was that this line, this stuff was blocking, forcing the onData to wait. It's non-blocking, or we say asynchronous. It does not force your onData to wait. onData doesn't care. It's done. It's gone. Now, from henceforth, this is how we shall be writing it. Is warming up first, then is ready second. Is warming up is the broader gate. During it, you want to skip everything. It is you saying, are we still warming up? Okay, then don't do anything. Then afterwards, it should then begin if your indicators are ready. Are the indicators ready? Okay, let's now start. So it just reads better naturally. So I'm going to be writing it this way. There's nothing wrong. It could have been either is ready first or is warming up second. But I just like the order like this. It reads better. So having these two, It goes back to what I said about on data taking a shape. In fact, I believe I wrote it as an equation, this equation. On data expects safety, signal, entry. And so you can start to see what I meant back then. The point now is, in hindsight, it's much clearer. So before we move on to a new thing in our curriculum, I want us to consider a simple problem. The aim or idea of the problem is to help see the necessity behind an is warming up. Because we have explained it, but why would you want to use it? Why say these should be non-negotiable? So let's entertain a simple problem. Let me paste the problem so we can analyze it. Look at this code. We are using is ready, but not is warming up. The next statement after the is ready is also saying that we are going to buy a boatload of SPY, basically a boatload of shares, if the current price is greater than the simple moving average 20. Now, let's see what can go wrong. So looking at the initialize and beginning from the top, execution starts line by line. Basically, it starts here, then comes here. I think I should use the dollar symbol. Basically, it does this, does this, does this, does this, does this. Remember, this is non-blocking. It's not going to wait to get the bars. It's just going to do it and say it's done. So what happens? This is gone. So now what happens? It does this. Self.sma is ready. It's not ready, right? So it hits false. It comes out. It does this until 20 bars, basically 20 days. And then what happens? It hits true and then comes here. But now look at what I want to show you. We're still warming up. That is, this hits 20 bars and becomes true. And once it's true, it's as good as gone. And because it's as good as gone, what happens? This triggers. Instantly, it buys a boatload of SPY while it's still warming up. So you can start to see why we need the is warming up guard. Because the indicator can become ready inside the warm up period. That is, I could make this, let's say, 400 days, 4,000 days. The indicator would become ready inside the period, and then the code would execute. The fix is warming up, and thus it's a non-negotiable part of the safety block that OnData requires. So here is the fix. This is the fix. So we come to number 4 and 5, market order and limit orders. I assume you already know what they are, so we're just going to focus on implementation with Quantconnect. But just for a quick reintroduction, market order means buy or sell right now at whatever price, current price it is. Limit order says buy or sell, but only at this specific price or better. You control the price, but the order might not fill at all. So to use them, they require parameters. Here are their parameters. Our focus on this lesson will be on symbol and quantity, number 1 and 2. The symbol means the symbol object, not the ticker. Again, we talked about this. So the quantity is the quantity. Could be 1 for 1 shares, 10 for 10 shares, 500 for 500 BTC. You get the point. Now let's see that of limit orders. And then it's pretty much the same thing, so much so that let me keep them side by side. The only difference is that the limit order has the limit price at number 3, and the market order does not have that. But generally, they are both the same thing. So here is how you write both of them. This places a market order of 10 shares. This places a limit order of 100 shares at a limit price of 200. So we come over to the last thing in this lesson, and it is the easiest: portfolio. There are two ways to write portfolio: the general way and the symbol object specific way. So in order to give a definition, I want to say that a definition should be divided along 2 lines. And so I will start with the first. What is self.portfolio? Self.portfolio is where Quantconnect keeps track of everything you own and everything you're worth. Your money and your stocks, crypto, etc., all in one place. Think of it like what your bank plus brokerage would know about your account. It knows how much cash you have always, how much stock or assets you're holding, how much profit or loss you've made, how much on fees you've spent, etc. It can tell you about your strategy's metrics easily. This is what is called portfolio. So the self.portfolio applies to the whole strategy, while the self.portfolio, self.apple, that is this guy, the symbol object way, applies to just one asset, one symbol object. Here we chose to say Apple. It could have been, here we chose to say self.apple. We could have actually just named it locally AAPL, but you get the idea. It's better itself. So it gives you knowledge just about that particular symbol you're trading or holding. So that's pretty much all about it. And then rather than have you try to understand attributes which you are not going to use in this lesson, I would rather give you this list. Let it simply just be that you look at this list, and we will go into the next lesson and then use them little by little. That way it sticks better than just a whole trauma dumping of information. So we have reached the end of this lesson. In lesson 8, we go on our practicals run for on data. I'll see you there. Lesson 8, Event-Driven Reinforcement Exercise 1 to 3. The entire claim of the previous lesson was, it was saying that your event-driven function, any one you can write, and I guess you may have walked off with the understanding that I was talking only about the on data. No, I was talking about any event-driven function. Any event-driven function you can write in Quantconnect always takes 3 things. Literally, that was the whole argument of lesson 7 and the whole idea behind systemization, that this was the shape. ED standing for event-driven function. It takes safety, signal, and entry. In this lesson, I want us to look at exactly that point, but as practicals. So don't worry, even if maybe you didn't get the whole gist of what I was saying, we're going to practice it in 3 exercises and make it very clear, crystal clear. So if you're ready to build on lesson 7, I'm ready too. So let me paste the trading strategies we're going to be working on. So this is trading strategy 1, this is 2, and this is 3, and this is the standard general format for writing a trading strategy. You remember it back from lesson 5. This is just the shortened version. So on that basis, right here we have 3 trading strategies. Trading strategy 1, 2, and 3. Each one has a complete signal and entry. The safety part is not written because it is implicit. A normal human trader does not try to start writing safety, so I didn't bother including it. And also, I've made the trading strategy simple. Let me explain what I mean by simple. For instance, a person might say, okay, this condition is insufficient, and then begin to write more and more conditions. Let me, continue. Hold on. etc. Essentially, what I'm trying to say is that a person might begin to look at this and say, okay, but it's just one sentence. And then what I was trying to say, but I guess not reaching the point fast, think of how you compose statements. You basically compose them by using and, or. That is, inside a programming language, you compose statements by saying something like this. Signal 1 and signal 2 or signal 3, and you can keep on going. The list can be immensely long. It can be an array of signals. So essentially, what I'm getting at very simply is this. The safety is one structure. The signal can be a whole list of statements. Each signal can branch to another signal, which can branch to another signal, which can branch to maybe a filter, which is also a signal, a crossover, which is also a signal, a threshold hit, which is also a signal, a reversal, also a signal. So it can branch any way you want. You can write it in any form you want. I simply call it signal. Now, the entry is simply one thing. This doesn't mean that you can't make each signal have an entry, but generally most people prefer to just say, this is my logic, this is my signal, and then this is how I enter. So that's kind of why I simplified it like this. You can compose it with and, or, if, then, and basically other programming logical statements. So I'm just going to keep it simple. And that was what I was trying to rant about. So let's split the page. I don't know whether to zoom out. Maybe that might be better. Okay, I could keep it like this. So this may be okay. Or I just leave it like this. Or no. Okay, so enough fiddling. So simple trading strategy 1. The asset is Apple, bar type is OHLC, resolution is 15 minutes. 15-minute resolution is non-native, so we consolidate up from the 1-minute resolution. The indicators are the SMA 20 and 50. It's going to be running on consolidated data, so we use indicator functions. Number 4, that is the next point, is so let's write the general shape of the whole thing first. I'm going to paste the general shape of the whole thing like a Lego block so that you can have a high-level view of the structure first before we start writing it. So this is a high-level view of the structure, the current shape of this simple trading strategy 1. So just reinforcing things a bit from the last lesson, this was exactly what I was pointing to in the previous lesson, that once you can see this exactly as you're looking at it, both for initialize and on data, it becomes terribly easy writing into it. It becomes easy writing your trading strategy, this one or another one or any other one, into code. And so looking at a beginner's perspective, a beginner just lands and sees this, just this page alone, and it's empty or it's filled with, something you can't comprehend immediately, and there's just that initial fear. No, it's actually very simple, because once you can see this, having this shape, a trading strategy becomes something very natural to write, whether a long one or a short one or whatever. So a lengthy trading strategy is just one with complex interconnected signals, because imagine a trading strategy that doesn't try to buy or sell. It has to either buy or sell. It's just not going to say, I'm not going to do any one. So that was what I was trying to tell you in the previous lesson. So let's focus and get started. Let's write the initialize for this trading strategy. As usual, like I said, I'm going to maintain a high-level view and basically be pasting the Lego blocks in. So number 1 is the asset plus the resolution. Like we said, it's non-base, so we're going to start from 1 minute. I'm going to replace this Lego block with this one, which basically is resolution.minute and symbol. The next Lego block is going to be the consolidator. So that's done. We're going to have to need to put this guy. So let me put that in. Now the next Lego block are the indicators. So we're going to fix that in. We're going to replace this line. So we've done that. We've put in the 20 and the 50 simple moving average. The next is the backtest period. So let's replace that brick. Let's replace that Lego brick with this Lego brick. And that is done, right? 450, 450. Okay, now the next and the last is the implied set warm up due to the event-driven function needing safety. So let's replace this with the Lego brick. So kill the pass, and there we have it. We have the full structure of 1 to 6. Now, I want to talk about the reason I use 750 bars, that is 750 1-minute bars. It's because 50 times 15 is 750. This, basically the period here, times the minutes resolution gives 750. That is, the SMA 50 needs 50 15-minute bars, which is 750 1-minute bars. We're going to warm up is what I'm saying. Now coming over to the on data, as we can see, we have nothing to do with this function anymore, because why? This is where we are. We're going to move all our stuff out of this and leave it as a pass. And yes, you can leave it as a pass and use this guy, because that's exactly what our logic needs to be in. We are buying when the SMA20 crosses above the SMA50, and both indicators are registered on the 15-minute resolution data. So it brings us to this function. So the first Lego block is going to be safety. We're going to replace it with our own Lego block. Okay, that's done. We put the is warming up and the SMA20 is ready and the SMA50 is ready. So that is done. Okay. Now, the next bit is the signal. To implement the signal, look at it. It's saying buy when the SMA20 crosses above the SMA50. So to implement the signal, we need something persistent to keep track of the current and previous SMA values. So first of all, let me just simplify my approach. We're going to remember this is being called every 15 minutes. So every 15 minutes, the new 20 and 50 bars come in. Let's save them. So these will be receiving the new bars all the time. This will receive the new 20 bar. Sorry, this will receive the new 20 SMA data, and this will receive the new SMA 50 data. Now remember, these are local variables. They will wipe, which is exactly what we want. Let me show you why. Down here, we're going to basically keep the previous. Let me show you what I mean. So what I want to do right now is the two bars are going to come into here. Now we are going to also then check. Imagine the check logic is right here. Imagine the check logic is right here. So it will do a checking. If it's true, if it's false, then it will save the bars as previous so that it will get called again. It will then take the current, do the checking, and then save as previous if true or false. So this is the logic to do that calculation, and I'm going to walk through it. So the two bars come in here, two new bars, they get saved. So right here, remember, for the first time ever, this is going to be empty. This is going to be none, and I should set that. I'm going to set that inside the initialize so that we don't have an error. This is going to be none. So for the first time ever, it's going to come. The two bars are going to say, okay, we're inside here. Do your calculation. But remember, we don't have a previous. So it's not going to work except we have something that checks for none right here. That is, we need to check for none right here. So let me put that. So we check for none. So the first iteration happens again. The two bars lock in. If it's none, it basically jumps out and then saves those two inside these global persistent variables. So the second time again, it comes and says, okay, safety, blah, blah, blah. The two bars again save. Now it's no longer none. So basically it now begins to perform the crossover calculation, which is either going to be true or it's going to be false. So if it's true, right, and we have not bought this asset previously, because remember the function is every 15 minutes, it will buy if it's true. So we don't want that. That is, if it's true and we have not bought previously, then please buy. Once it does that, it then saves again. And basically that's just the whole gist of the logic. So we're going to backtest it. Okay. So let's backtest it. I should keep my entry properly. Doing one final check. It looks good. So let's click backtest right here. So while that's pending, let's go to the next trading strategy, that is trading strategy 2. So for trading strategy 2, let me open this a bit. For trading strategy 2, the asset is SPY, and the bar type is OHLC, and the resolution is daily. Daily is native, no consolidator is needed. That's good. The indicator is the RSI, and since the since the data is native, we are going to add it using self dot. The signal is RSI based, that is, when the RSI drops below 30, that's oversold. When it rises above 70, that's overbought. The entry is a market order with 200 shares. So before we write the initialize, let's go look at the back test. And so, we made $7.99. How interesting. So, has it finished? Yes, I think the backtest has finished. So, we made $7.99, and fees basically took $1. So, we made, I guess, net profit. Wow, we made minus $1. Well, that's just basically it. We never sold, so we have an unrealized of $8.99. So, that's basically it. I'm going to close this and we're going to fully focus on simple trading strategy 2. If you ever want to see a list of all your backtests, that's exactly where you come to, backtest results. You open it and you can see your backtest that you just did. So we're going to close this and we're going to focus fully on a simple trading strategy 2. So without wasting much time, I'm going to fill the initialize and we're going to get started. Rather than starting from pasting Lego blocks again from comments, I'm just going to do this because you already know the initialize. So we're just going to start here. I already have my set warm up. That's the only thing that is different. So the warm up basically says 14 bars, resolution.daily. Why? Because the resolution here is daily. So I am loading 14 bars in because the RSI period is 14. Now, the signal, first of all, let's add the safety, then we'll talk about the signal. So that is safety, is warming up and is ready. Let me aim it differently. All right, so I renamed it because I was using the indicator name. Okay, so the signal is basically buy when RSI drops below 30. Sell when RSI rises above 70. So these are basically Boolean statements and they are easy to write. So let's begin. So let me paste the first buy side logic. So this says, if RSI value is less than 30 and we have not bought before, that's what the dot invested is saying, then place a market order for SPY with a fixed, with 200 shares. Now, the next thing is supposed to be an elif statement. If you know Python, it's elif. So let's paste the same block. So if RSI value is greater, I should have put equal to. I think I'm going to do that. Yes, let me do that. Okay, drops below. Okay, so I'm not going to do that. So if RSI value is greater than 70 and self.portfolio, we haven't bought before, then please, by all means, do the market order here. Now, the next thing is why is this negative? It's negative because you buy, when you write a positive symbol, you're telling it buy. When you write a negative symbol, you're telling it to sell. So that's literally why it's positive or negative. So, and this is the full strategy. Note there is no custom resolution. It's resolution.daily. If there had been a custom event-driven function, then all this stuff would have been inside that custom driven function, but it's not. So we save. Now we're going to backtest this because this is the full strategy. And so I'm going to click backtest. So while that is happening behind the scenes, we come to simple trading strategy 3. So here is the asset is EURUSD. The bar type is OHLC. The resolution is 1R. It's native. Quantconnect supports resolution.R directly, so no consolidator is needed. So exactly this is like trading strategy 2. Nothing much here which is alarming. We buy when the EMA 9 crosses above the EMA 20. It's literally exactly like this structure, the signal. So let's begin it. I'm going to paste the base structure that we used in lesson 1 for it. So I'm going to remove this. So this is the base structure, and let's go through it. We have set start date, end date, cash. We basically have EURUSD, it's a Forex. We have the two native indicators. We have the warm-up, 21 hours, sorry. Why? Because the EMA 9 requires 9 hours. The EMA 21 requires 21 hours. So I figured, okay, give me 21-hour bars. Give me 21 bars, sorry, 21-hour bars. So we put that in, and basically those indicators are ready. The 9 is ready at 9, the 21 is ready at 21. So this is the memory for the crossover detection like we had in the first strategy. So now the next thing is the on data. So basically I'm just going to paste the on data with the safety brick loaded in. So that is safety. We have the is warming up and we have the is ready. Now the next thing is to save the current values. So exactly like put that there. Now the next thing is to check for the logic. So let me paste that. And so we're checking. Remember the first run, let me show you how it's going to work. This is scoped to none. So the first time this happens, right, the indicators are ready, and it disappears. That's no longer our business. Now, the first two values come in and they get saved locally inside these two variables. Then remember, because it's none, we do a skip, right? And let me add the last line. We do a skip and they just get directly saved into this as the first instance of values inside the global persistent variables. So it gets called again, then the two values get saved into this, then the new calculation can begin. And then if we crossed above and we have never bought before, then we want to buy the EURUSD. We want to buy 50,000 EURUSD. Let me make sure that's correct. We want to buy, yes, 50,000 units of EURUSD. And then this is the limit price, 1.0917. And that's all. Reinstalling back the safety. So let me zoom out so you can have a better view. And I guess I could close this, right? You don't need it anymore. Yeah. So zooming out so you can have a better view. Yeah. So Before we backtest this, let's look at the previous backtest. So, what did we make? Whoa, we had a good net profit of $6,000. Nice. We had a good net profit of $6,000. So we can close this. And if we go to backtest results, it's right there. The muscular yellow-green cow. That's what we requested at 2026-07-13. This was done at 1 o'clock, 1:31:32. This was done at 1:38:33. So let's come here and run this. Let me save it. So that is saved. Now let's click backtest. This is well-dressed blue dogfish. I always typically find the names funny. So let's close this. We reached the end of lesson 8, and so you can see that filling in the on data is quite easy. The pattern is that every strategy you write is a translation problem, because once you can view it as a translation problem, then it's kind of reducible to just a tree-chip structure. And so that's essentially this. Another thing I want to talk about while the backtest is done, is the cloud terminal. With the cloud terminal, you can see exactly what the engine is doing. And if you debug, for instance, let me write this. If you ever want to see what's happening, let me add a self.debug. Hello, I am your course instructor. The reason I added it here and not in the on data is, if you remember, this is being called per data. It's being called per data. So the start date is 2024. If we had added this inside here, we would be flooding the cloud terminal with noise. So I simply added it here. So let me backtest this again. Save, backtest. So the well-dressed blue dogfish. So the equity, basically, it didn't fill any condition in, right? Yeah, it didn't meet any of the conditions. So we're going to close that and wait for the alert green cobra. All right, so let's wait and watch the cloud terminal. So this is where we are. It built the project when I clicked save, and then it received the backtest alert green cobra request. Let me zoom in. Okay. So you can see the next thing it's saying is, what is it? Initializing my algorithm. It's launching analysis for, this is, I guess, my algorithm's internal name. Now, right here is the stuff I printed out. Hello, I am your course instructor. So I guess that's literally all about lesson 8. So I'm going to see you in lesson 9, the last lesson of this series. Congratulations. So lesson 9. Welcome to lesson 9, extending the foundations. Welcome to the final lesson. Take a breath. You have come a long way. Let's look back at what just happened across these lessons. In lesson 0, we introduced the course. You saw the curriculum, the prerequisites, and what the course is designed to do. Nothing was written, nothing was run, just a promise. By the end of this course, you will go from 0 to live trading. In lesson 1, you wrote your first line of Quantconnect code, a class that inherits from QC algorithm. That was it. 3 non-negotiable steps: use a class, inherit QC algorithm, import the import statement. In lesson 2, you initialized that class. You learned what initialize is for, and you started filling it in, setting dates, cache and add in your first asset. In Lesson 3, you got the class to receive market data. You learned what an onData is for, what an event-driven function is, how the engine pushes data into your algorithm. In Lesson 4, you got the class to place a market order. You just slapped it on it. The buy and hold strategy was now complete. A class that initializes, receives data, and acts on it. In Lesson 5, we gave all of that a spine. 4 pillars: local and global variables, the security and symbol object, indicators, and consolidators. Everything in Initialize traces back to one of those 4. In Lesson 6, you translated 3 full trading strategies into working Initialize code from plain English. Assets, bar types, resolutions, indicators, straight into Quantconnect. Those were real strategies. The same format you will use for the rest of your life on this platform. In Lesson 7, we did the same thing for onData. We found its shape. The bare minimum structure it accepts is 3 Lego bricks: safety, signal, entry. We called it the 3-chip. In Lesson 8, you wired 3 full onData methods from scratch. One with a market order, one with an RSI threshold, one with a limit order and a crossover. Each one was just the 3-chip filled in. Now you're here graduating. You now have the fitting foundation and picture. From here, everything you add is an extension of what you already have. A new indicator is just a new input to the signal brick. A filter, maybe volatility filter, again, that's a new input into the signal brick. A stop loss, again, that's a new condition into the entry. A position sizing rule is a calculation inside the entry. The idea of this course is to provide the basic ground on which you can continue to extend and build so that you're not starting from zero all the time. Every single thing you now can learn, and when you learn something new, you're plugging it into this system you already understand. So, having fulfilled the required goal of this course, it was a pleasure being your teacher. Don't forget to like and subscribe, and till we meet.